Hello, I'm Paul Ouston-Creasy from View City. Relatively newly formed company from a visualization company, a surveying company. The surveying company supplied this lovely model of London and other cities. And we, from Wagstaffs, were a sort of arch-viz company that supplied some of the Unity development. What I'm showing you here is like a pre-production prototype of a product we're launching this month to mainly architects, developers, city planners in London and also Manchester. And we're also modelling Belfast, Dubai, and potentially other cities in England and hopefully further afield. We have some of Paris as well. So we're basically disrupting the planning world, which is a very rigid old boys network, ripe for disruption industry, and sort of entering the sort of smart cities space as well. So we came at it from a planning perspective, but we are now starting to look at data visualization, which I'm interested in, and just sort of more general smart cities and strategic planning for cities. So we're running like a 250 square kilometre model at the moment. We're loading in tiles, so you'll see as I move around we're like instantiating bundles. And we're also doing that with the terrain in the production version. So we basically, there's no limit to the scale we can go to because everything's instantiated as you go. I'm just going to run through the hopefully you guys recognise this. Looks like it's been stretched. Is that stretched? I really hate stretched things. So we've got sort of a consented timeline. You can start to see the stuff that's happening in London, which is interesting if you're a city planner. It's worth saying this is kind of accurately projected in the Ordnance Survey Coordinate System. As a big part of this is accuracy, so we're able to place objects from GIS systems and external databases quite accurately, which is important for planners. We've also got some proposed stuff in there and some sort of secret stuff. So yeah, we're using real-time lighting. So this is at the moment real-time lit. Got U-Sky Pro, and sort of accurate time of year and all that sort of stuff. There's a lot of protective views in London which are important for the planning world, which are sort of accurately placed in 3 dimensions. So the views to St Paul's are protected from long-range views, so you're not allowed to build inside these view cones. You can see some historic buildings just sort of coming through there. There's also the river prospects. Let me get this right. Downstream. This is kind of quite striking, I think, because a lot of people recognise this view of London, and it's quite interesting just seeing how much it's about to change. So that's as it is today, and in the next sort of 10 years. And then we've started to overlay real-world photography into this to sort of prove the accuracy of the model. So you can see that building on the right is being built at the moment, and we've topped it out in our 3D model. The most expensive part of this whole thing is the real-time reflections in the water, which I wish we'd never added because now everyone loves it and we can't take it out. It's like, why did we put that in, you know? But yeah, it looks great. Tanaku, I'll just jump out of that. We started to work on some measurement tools, but I suppose every time we show this to architects and developers and city planners, they come up with new features, and that's why we're looking to recruit, because we've got a list of features we want to implement into this, like measurement tools, data integration. We're speaking to Spatial OS about doing city simulations and using this as a model for their simulations. So there's all these integrations we want to include because we see this as kind of a smart cities platform because we have this great model and Unity is such a great platform to do that in. That we're hiring developers to help us integrate new tools and sort of feed the development community and the planning community with what they want. So we just put this measurement tool in really quickly just to show above ordnance datum, AOD is the height above the sea level basically, so you can quickly check what buildings and what heights buildings are at. But it's just the start of sort of the measurement tools suite, and we'd like to add way more to that. We've also got a data visualization section, so this is pedestrian transport accessibility, which is interesting if you're involved in development in London. So obviously central London's all very red. The Queen actually has a bit of a black spot for pedestrian public transport there, so she's got a bit of a walk to the nearest tube. There's Buckingham Palace. There's all sorts of layers, non-domestic dwellings, house prices, nitrous oxide pollution. Yeah, everything's red, right? Nitrous oxide, which is slightly more, so the cheaper houses you don't have so much pollution at least. But like I said, we're just really starting with the data integration. I think that's one of the most powerful things about this platform. The grey model is really just the base. Like what you put on top of that grey model is where the real power is. We'd like to do some more sort of complex calculations, like there's a whole field of rights to light, calculating light levels from windows, calculating where a building, if you add a new tower, where's that building visible from in London, doing raycasts, which involves a lot of sort of bias sampling, which we need some sort of heavyweight brains on, or more heavyweight brains on. So we're sort of facing some quite nice technical challenges, which aren't, it's not a game, but it's like, they're interesting challenges if you like that kind of thing. In terms of its usefulness to developers and architects, they're going to be able to do runtime model importing. So at the moment we've just got FBX importing at runtime. So they can model their building in Blender or SketchUp and they can chuck it in here. At the moment that process takes months and then they can just do it really quickly and check all the views around London. So they can put a model in, say create views, select the tower they're trying to assess, and then just sort of fire down cameras all around to assess the impact of that building on the view, and also with the cumulative of the other consents that might affect that view. And you can kind of walk around and the whole thing's updating with like a geolocation and stuff like that. We can fire, this is quite fun, so we can fire and see the view from any building, and this is quite satisfying. So there's a new development on Blackfriars Bridge, which is selling for millions and millions of pounds. And all the marketing material, this yellow one here, the sail-shaped thing, One Blackfriars Berkeley Homes, one of the most sort of premium house sellers in London. And if you see their view, this is all the marketing material, all the brochures have this view of East London in them. And if you wind the clock forward, it gets slightly worse. I showed the guy from Berkeley Homes and he was like, yeah, like we're not legally obliged to tell our clients, but it might be reputationally damaging if we don't. So yeah, it's interesting planning. I find planning in London quite interesting. Like they just built a new Tate viewing gallery here, and you can see into all these expensive flats, you know, and they're complaining, oh, we have to close this at 6, everyone's looking into our apartments. Turns out the head of planning at Southwark Council has one of those flats. He's the one that gave it permission, you know. So with this tool, we kind of hope to maybe overcome some of those problems. We've also started to play with texturing buildings, so we've got a little demo on Oxford Street where we just chucked in some people and cars and photo textures to show that you can take it up to another level. It's such a shame this is stretched. It just looks stretched from here. So yeah, we'd like to do more of this, so procedure generating pedestrian flow and traffic flow. And I think that's something we'd like to explore with Spatial OS because they have this lovely way of simulating millions and millions of entities. I think we could do some really cool stuff with using their platform to crunch big simulations in this model. Yeah, exactly. We've got the tube on there, geographically placed. It's quite disturbing, not even TfL have a complete map of where the tube goes underground. And if anyone builds a tower in London, they make them survey it themselves because they don't want to be liable in case they build through the tube. So there's all like Victorian like drawings and like a basement somewhere showing where all these tunnels go, you know. We've got one live data feed in here, which is the TfL traffic cameras. So this is like live video now. It's like a 5-second loop every 2 minutes, so it's a bit of a cheat. But whenever something happens on the news, we're like, get into the city, see if you can see it, you know. And invariably it says, oh, TfL is using this camera, please move along. Like this one, for instance, recently. So yeah, that's View City as it stands today. But like I said, we're kind of moving forward very fast. We're just sort of going for a round of funding now to model all 32 London boroughs, which is, we have 250 square kilometres now, but we're looking at getting to 1,000 square kilometres within about a year, maybe less. And like I said, modelling other cities, hopefully with some funding going out to other capitals and disrupting the city planning space using Unity. And people always ask, oh, why don't you use Unreal? It's more powerful. It'll almost have the performance. And we always come back to the fact that every meeting we have a new feature request or a new data feed to bring in. And I feel like Unity has the agility to be able to develop at speed and quickly and prototype things. And we're basically totally wedded to Unity, and I don't think we're going to jump ship anytime soon. And we're recruiting. And that's the end of my presentation. Thank you for your time.
Right, so hey guys, as he already introduced me, I'm Adrian. So today I'm going to talk about my journey of building a custom heatmap system for Unity, especially, to pretty much analyze the effectiveness of level design. So a little bit of background about me. So who am I? Pretty much a mainly software engineer. I do a lot of web stuff, so front-end, back-end, APIs. I also do native apps, so mobile apps, Android, iOS. I'm also a game developer, so I'm mostly into like mechanics. I'm very into networking as well, and also being like a team leader from time to time in like game jams and things like that. Also, as he already said, I'm a University of Greenwich graduate in games design and development. And if you want to follow me, yeah, there's my Twitter, there's my GitHub. The things that I'm going to show today, maybe I'm gonna publish it on GitHub as an open source thing, because I think it's a great tool that can be expanded maybe. But for now I left it because it's quite like it was customly made for this specific project. So yeah, and this is a joke for whoever plays Hearthstone and knows the quote, "Who am I? None of your business." I don't know why John Cena is there, to be honest. I have no clue. So as an overview of what I'm going to show, so pretty much it's going to be like, it's going to show the importance of a heat map system inside pretty much any game, but mostly I'm going to focus on the 3D maze-like game. I'm going to show you how I've actually implemented, so what goes into doing that kind of system. And I'm going to analyze, I'm going to show you the analysis that I've made on this system on a specific game. So why is this tool important? Well, pretty much it informs level designers what goes wrong in a game level. So if, for example, someone gets stuck, you might know that if the level is too difficult, if the map has some problems, if some parts of the map are not explored enough, or things like that. So I think it's a really useful tool to kind of improve over time, I guess, the feeling of a game, and the quality of a game. And I'm pretty sure like most of the companies use this kind of system to kind of improve that. So this is just my approach of building such tool. So why did I choose it to build it myself? Well, I just pretty much Googled any Unity analytics system on Google and found one which is made by Unity pretty much. But at the time when I built this, it was still in beta, and also it's a paid service, which I didn't want to do because, yeah, university stuff, who pays for things? I'm a student. So pretty much I couldn't find any free solution for that, and I just decided, yeah, let's do it myself. Because I actually had an interest in data analysis for quite a while, so I said, yeah, let's give it a go. So pretty much I'm going to show like the infrastructure before I actually show you the tool. So how I thought about this, I thought, you have the Unity client. We're going to have some sort of a cloud API server, which is going to get the request and all that. And we have a database which is going to store the data that I'm going to record. So that's how it's kind of put into a 3-point layer. It could be more complex. Obviously, there's space for expansion. You could scale it to 100 machines and things like that. But I just preferred to keep it simple, just to do the job. So as you can see in the slide, pretty much I'm sending JSON to the Node.js. I have like 16 API endpoints for specific things like player position, if the player, I don't know, died, if the player left the game, and things like that. And then that server saves the data into the MySQL database, and whenever I need to see that data, it kind of calls the same server and pulls the data out. So because to test this tool, you obviously need a game. So I had to build a game which was a choice of, as I said, a 3D maze-like game, because that kind of proves my analysis on level design concepts. So maze-like kind of shows you if a player, pretty much proves the player's decision in specific scenarios. So the game is pretty much the player is put into a thief role, which was thrown into a dungeon, and he has to escape, and he has to find a key which is hidden in one of the chests across the dungeon. So obviously he needs to escape. That's the main objective. So I'm going to show you the main map layout of the game. and you'll see why this is relevant in a second. So this game had 2 levels. So the level 1 was a more easier one because it was like more of an introductory level as well. So I did want to kind of show him some tutorials and things like that to the player. So this map, what is really interesting, and I'm going to show you here, is that you can see the way, hopefully you can see, right? The way I put the lights in here is like very like focused into a path, let's say. So it isn't pretty obvious that the player will get to these rooms, as you can see, because there's no like torches in here. So from a player perspective, you're going to see in a second, it's not that obvious that you can go in here. So I was wondering if I put the lights here, if the player will be driven to actually explore those rooms or not. So that's what I've done with the first level. I kind of tried to guide it in a one-way path to see if that actually works, if the players follow the pattern that I set up for this level. And you're going to see in a second if that actually happened or not. And this is the second level, which has, as you can see, the lights are spread more evenly. So it gives, in my mind, it was a design choice that it maybe gives the player more options to explore. So he feels like like over a more open space area that he could find more things. So then again, as you can see, more lights spread evenly across all the floors. I'm going to show you very quickly. This is just to show you like what the game does. So the games had also like some sort of traps, so that they will give a player a challenge. So he'll have reasons to die. So as you can see, this was a gas trap, which kind of removes the health over time. This is a flame trap, which whenever the player gets in, he kind of gets hit by this. There's a boulder trap, which this was an interesting one because it's a very like surprise element. As you can see, the door over there just opened up and then it kills the player suddenly. So this one was very interesting to analyze if the player actually realized that the boulder was there or not. And a soul trap, which again, it is quite obvious, I guess, but yeah, maybe it has a surprise element in it, I don't know. And I had like these treasures, which again, this was an intentional design choice. So one of the chests is like just purely the model, no effects added into it. So if I play this, as you can see, it's just a normal chest that you can open. And the other ones were having actually some flashing lights and things like that. So I was wondering if players would notice the second one more than the first one, obviously. And that's just from a data perspective, not necessarily, because some things are obvious. Like, yeah. I've made like an intentional stuck point to see if players actually get stuck into this area, and yeah, it was actually proven that I was right. And I had an end screen which kind of makes the player like in the data side of things, it's like he finished the session, so I know exactly if the players finished the game or not, or things like that. So pretty much the Heatmap preview system. So I have 6 different types of maps. So I have an overall map which shows pretty much all the ones underneath into one single map, so you can analyze everything at once. And I have specific ones, so like player path, to see exactly where the player went, and that is represented by colored heat maps. So you have different colors for how much the player stayed in one place. You have open chest map, which shows where the player, which chests in the level the player opened. Death points map, life loss map, and drop off points map. And a little preview of how that system actually works. So now I'm in the first level, just exploring around, opening a chest, and pretty much just wandering around. And afterwards, you'll see the heat map representation of the actual activity that the player did. I think it should be here. Hopefully, yeah. So as you can see, I'm choosing a username because it was like account based. And then I choose a login session, and then I choose a game session, because each time a player would start the level, would generate a new login session. So as you can see, it goes into a very nice transition to a top level view of the map. And as you can see, probably from there, it's exactly the same representation that you saw in the video, but like on a data kind of side of things. So you can see exactly the player went into that room, it opened up those chests, and then it exited the game at the end. I don't know if you noticed, there's like a little red square as well. So in the beginning I stayed in one place for a while just to kind of show that, but it's very, very barely visible. So now, I'm going to show you a demo of how that actually works. Hopefully it doesn't break, obviously. And I'm going to use a local one, just because I don't trust the Wi-Fi. So I hope this was one of the, nope. If not, I'm gonna just create a new account just for log. I'm gonna call it log. Yep. Okay, so I created an account. It automatically logged me in. Obviously, you have some tutorials and things like that. But the main thing in here is that obviously I can do exactly as you saw in the preview. I can walk around. I can open up chests. And I'm going to try to show you something different now. I'm going to go like upstairs because I haven't been upstairs. Because you can actually, in this heatmap system, you can go through each level of each floor of the level, so you can transition from each of them. And in here, you see I'm losing health over time, so hopefully you should be able to see that on the map. This was the final chest, so as you can see, it says that I got the key. And now I'm going to go into the second. Oh, actually, I'm going to stop here just to show that. So I can, as you saw in the preview, I can choose my new account, log. I just have one login session, as you can see, and one game session. And if I click on the overall map, hopefully, if it doesn't break, as you can see, that was the path that I took right now. And I can transition from the first floor to the second one. And as you can see in here, hopefully, it's on red. It's not a good color scheme. Accessible. Change that. In here on red is like the marks where I've lost health over time. So as you can see, the player lost health in here, and this is very useful. Like, because I set up a challenge in the second level where the player had to go through a similar gas just to get to the end chest, and that shows you if the player loses health like a lot, and if the level is too difficult or not. And the orange box over there is the chest that I just opened. They might look like just boxes, but that's actually a model. Yeah, so this was the first level, and now the second level. Again, the same thing. And let's say I'm gonna die here. Hopefully, it should show up. Yeah, I died. Such a noob, I guess. And my own game. So now if I go again, as you can see, now I have another game session because I died, so it creates a new game session every time you die. So you can analyze it, obviously, each section. So as you can see in here, marked with an X is the point that I died after I opened up the chest. And in this visualization, it's just more of like an overview, but obviously I have this data stored, and I have actually the reasons why the player died as well, which I'm going to show you right now. Oops. Sorry about that. Okay. So pretty much the test results. So because this was in a uni project, I had 23 accounts, which mostly were students and friends of mine who played the game. Thanks for everyone in this room who played that. So I've analyzed their data, obviously, after a nice gameplay. And I pretty much, out of the whole data, I figured that 17 out of 23 players finished the game completely. So some players actually dropped off. So that was the most interesting part because I could analyze why they dropped off. Again, the data offers me information like if the player were running or walking through the game. So that might show you a different type of player. It might be like an explorer or just like someone who really wants to finish the level as quickly as possible. So that was an interesting one as well. And this is just data gathered from the player's position. And the state of the player, if he's running or not. As you can see, the first level had a 100% chest discovery, so pretty much every player found each of the chests in the first level, whereas the second one was a bit more tricky, so because some of them dropped off as well, they couldn't manage to find them all. this is the empty chest. So that was the final. What I mean by final chest, maybe I got you confused there. The final chest is the one that has the key, who lets the player escape the dungeon. The empty chests, obviously, are the empty ones who doesn't have the key, and these were mostly the most interesting ones because they were the ones that I told you about, the flashing effects and placed like in specific areas that were intentionally. So as you can see, the second level, because I had so many lights in there, I got a 100% opening of empty chests. Whereas for the first one, because I put the lights specifically to go to one direction, it was just 31%. These are the test results for the death reasons. So as you can see, mostly players died because of the gas trap that you saw, the one over time, because especially in the second level, because it was a bit of a challenge. So this is how you can use the data that I just gathered from the same visualization system. And this is the, let's say, the most interesting part is where you actually analyze each player's walking pattern and see if the design choices work. So as you can see, this is the first level. As I explained to you before, I've made it intentionally to actually follow that pattern, as you saw. And this is the test results that I gathered from the players' gameplay. And as you can see, they pretty much follow the same pattern. Some didn't, like as you can see, like in here, the yellow point here means the drop-off point. But most of the players were actually following that pattern, which means my level design decisions were actually right. And in the second one, as you can see, it's a bit of a more spread pattern. So players were actually exploring more, trying new traps, seeing if they die or not. I found it very, very interesting to analyze that. This is a funny one. I only had one player who actually got stuck into the intentional stuck point that I showed you before. This one was an unexpected one because I didn't realize that my system could actually spot some map glitches. So pretty much one player actually fell through the map. I don't know how. One collider just messed up. And as you can see, you have a whole a whole data visualization of how he fell through the map. So I know exactly that happened on those stairs, and then he fell through, which is a very good. So this is a very good tool to test the map as well. So a bit about the performance. So as you can see, with just a single CPU server with 500 megabytes of RAM, so this is a cloud server. It was hosted on DigitalOcean. As you can see, it's not using that much because I'm sending the data once every 5 kind of Unity units. I'm sending the data that I've recorded. So it's not. I've tried to optimize it as much as I could on the time frame that I had. I obviously did some data protection, so pretty much encryption and having a token for each player, and that token actually it's required to call the API request as well. So if you want to get any data from a database, you'll probably not be able to because you don't have a token. That only happens from the game, and this whole data transaction was over HTTPS, so hopefully it should be secure enough, I guess. But nothing secure enough, so I'm not gonna go into that. So yeah, any questions? That was my presentation.
I was super curious to see them all overlaid. Have you done that, like overlaying everyone's movements into one?
No, I don't have that representation. Okay, I know that was a feature that Darryl was requesting as well. That was a bit more complicated to do because a lot of stuff I tried to do it, but a lot of the things were overlaying on top of each other. So I needed to create some sort of algorithm which kind of knows how to calculate things. So those paths, for example, I needed to know exactly if I have like 5 or 10 points into the same area. It should like color differently. Yeah. I didn't manage to do that in time, unfortunately, but it was on the plan. It was one of the things that like for future development, let's say.
Okay, so hello everyone. Probably the only IHV here, but that's okay. The talk's not going to be as like graphics fancy as Adrian. There's no demos, pictures, but that's pretty much it. So I'm Frédéric Gagné. I'm working for Samsung as a developer relations engineer. And so what we do is essentially the bulk of the work is ensuring that games work well on our devices, and just making everything good for mobile GPUs. That's pretty much the bulk of the work here. Okay, so we're a very friendly team. Unfortunately, we're not hiring yet, but we will be, hopefully. So we're focused on three things, essentially. There's the DevOps side of things, which is the technical support we provide to developers targeting our devices. We've got developer relations as well, and that's just reaching out to as many people as we can so that we sort of get accounts. And for that, we've got an account manager who's looking after this. We've also got standards as well, and that's the team that's working with Kronos. That's for pushing for extensions, making sure that Vulkan's working well, OpenGLES, and other things that we deem relevant. So I'd like to thank the team at Samsung, because I pretty much haven't written any of these slides. I just pretty much threw some stuff together and made sure there were notes, and that was pretty much it. But I'd like to thank Suwon, Junyoung, and Jungwoo Kim from Samsung Mobile, who aren't here today, unfortunately. Okay, so, oops. I'll describe what Vulkan is for a bit. So I don't know if any of you know about Vulkan or have used it before. How many have used Vulkan here? Okay, so just one. Just you. Any of you know what it is or what it's about? No? Okay. So I'll try to explain as much as I can, but obviously it's a graphics API, so it's kind of hard to explain everything about it in depth. But essentially, it's an open standard API developed by the Kronos group. And so the idea is we essentially wanted to go away from this OpenGLES graphics model and develop something that's brand new and that's very thin. So the idea is, as OpenGLES, it's cross-platform, so it works across not all devices, but mostly. It's not limited like DirectX 12, but I'm not going to do comparisons. And as I was saying, it's very lightweight. So what I mean by that is, with OpenGLES, if you're doing something, if you're rendering stuff, it's very synchronous. So essentially, you have my points for the triangles, which are vertices, render that, draw my pixels, and that's pretty much it. Whereas with Vulkan, you really have to think of how the driver is going to take this work and sort of submit it to the GPU. Again, it's very efficient, at least from what we've noticed on our devices. So what I mean by efficient is some more stable performance. So on mobile devices, unlike desktops, the longer you play a game, the more it overheats. So as performance runs to 60 FPS for like 5 minutes, afterwards it's like 20, and that's called thermal throttling. But what we've noticed is that performance remains stable with Vulkan, and there is less thermal problems. So, oops, yeah. So what we've done with Vulkan, that's just our roadmap. We started with developing the Kronos standards, and that was before Vulkan was actually released. We were talking to lots of companies and trying to make sure that Vulkan was in the right shape for people that were going to use it. Then afterwards, we used in-house drivers, worked with ARM to get the best drivers possible. They didn't pass CTS tests, but at least they worked. Then afterwards, we've done some demos just to prove some of the sub-teams at Samsung that Vulkan does indeed outperform OpenGLES in most cases. And then afterwards, along with that, once Vulkan was more stable and the drivers were also stable as well, we decided to contribute to a few game engines, Unreal Engine and Unity as well, which is what the talk is about. And what we're doing now is reaching out to developers who target OpenGLES, but we're mostly interested in Vulkan. And what we try to do is essentially point them towards the right tools they can use, and also advise them as to what's the best way to develop your game and make sure that it runs optimally on our devices. And when I say our devices, I mean the flagship Galaxy series. Okay, so that was one of the demos we've worked on May 2015. That was actually, again, way before drivers passed CTS tests, and that was on a Galaxy Note 4. So the blue line there is showing the FPS with Vulkan, and the one below is with OpenGLES. And on average, we've noticed over well, sort of a long period of time, about 23 frames per second. And whereas with OpenGLES, we've noticed 14 frames per second. The demo is the same, but the reason for Vulkan is faster is just because the driver is not doing it as much work. So if you know what you're doing and you're doing it the right way, you're sure that it will run as optimally as possible. And that's the idea behind Vulkan, essentially. So that's, yep. As I said, it doesn't look very nice compared to the other demos. There's just a demo we developed. It was a 4-day deadline, so obviously expect that stuff. And that was at the marketing team's request. They wanted us to prove that Vulkan is indeed faster than OpenGLES. So we developed a demo. It's 2 separate demos. The one on the far left here is running Vulkan. The CPU load is 19%, and it's running at 32 frames per second. And then right here is OpenGLES, 45% CPU load and 11 frames per second. And as I was explaining before, in most cases, it's always the driver overhead. The amount of draw calls you do, there's no way to record command buffers or to essentially design your application to make it mobile friendly with OpenGLES. So that's why we essentially prefer Vulkan. After that, we thought, okay, drivers pass CTS tests, everything's running well, Vulkan is the best in some cases. So we decided to reach out to companies. So SEMC, which stands for Super Evil Megacorp, kind of a weird name, but whatever. Nexon, who were developing HIT, and EA, based in Australia, that were developing Need for Speed. So what we've done, which was mostly a team in Suwon, we ported their game that was running in OpenGLES to Vulkan, and with that, we made sure that it runs as fast as possible, obviously to prove our arguments, and we were able to, with their help as well, push that to the market, in our case, the Galaxy App Store and the Google Play Store as well. Okay, so I'm showing just 2 games here, not Need for Speed. The one on the left is Vainglory. I don't know if any of you know about this game. I didn't know until I saw these slides. But the one on the far left right here is OpenGLES. It's quite small, but if you can see the chart right here, that shows the frame rate stability. And it's showing right here that with OpenGLES, while it is quite high, it's still not stable. So you get these spikes, which leads to annoying gameplay, because all of a sudden you're reaching this level which has lots of fancy graphics and cool stuff, and suddenly you're running at 2 frames per second, and it's just horrible. You have to go back to this level that has nothing, a few trees, and probably just one building, and finally it's running at 60 frames per second. And we consider that to be unacceptable. So we ported the game to Vulkan, and we've noticed with lots of optimizations and obviously very tight deadlines and hard work, the frame rate was more stable. We kept the game as it is. We didn't add any post-process effects. It's literally the same stuff, except it's a different graphics API. With HIT, though, we were able to add depth of field and other post-process stuff. And that was because the Vulkan version really outperformed the OpenGLES version, giving us essentially more time in terms of frame time to add more stuff. Okay, and that's our current partners. We're hoping to add way more to that. We have a few, but it's kind of hard to fit in the slides. But we're working with Netmarble, Super Evil Megacorp, that were developing Vainglory, Digital Legends, which is a small studio, but they're really good, and they're doing this game called Afterpulse. Nexon, who are doing Hits, First Touch Games, which is based in the UK, and they've worked on a game called Score Hero and Dream League Soccer, which is also Vulkan-based on the Play Store. Deep Silver Fish Labs have released their game called Galaxy on Fire. I don't know if that's a pun, but it's a good game anyway. Creative Lab as well, and Crow Team, who've literally started using Vulkan as soon as it was released. They're mostly focused on the PC side of things, but they're also very interested in Android and want to make sure that their game runs there. And then CodeSync as well, who are developing games with Unity actually, mostly VR stuff and a few, I think, Vulkan stuff as well. Okay, so now that I've sort of explained what Vulkan is, I'm sure that didn't help, but I tried my best. I'll talk about the actual main point of this talk, which was what we've done with Unity as a partner. So the collaboration model works this way. So Unity develops the engine. They've got all the tools needed for the developers. So profilers, forums, documentation, all of these things that makes it easy for developers to actually develop a game. And what we provide is the OS and framework. So obviously Android, probably in certain cases Tizen, and the graphics API provided as part of a driver on the device, which runs OpenGLES, Vulkan, and the device as well. So what I'm trying to say is you kind of need both if you want to run a game on a Galaxy S7, S8, or S6, which actually has Vulkan supports. Okay, so in sort of, not really in depth, but high level, what we've done with Unity, we've been working with them for quite some time, applying lots of patches and making sure their engine runs optimally for our devices. So we improved the Vulkan renderer. It was mostly just us working with companies that were using Unity, and as they were porting their game to Vulkan with Unity, we noticed, okay, that's really, really slow. We looked at the source code and we noticed, okay, that's definitely not the way you should do things in mobile. So as soon as we noticed that, we decided, okay, we'll just provide patches to Unity, and they were keen on getting that. And as we do this, obviously we had a separate Unity version, but still, I think it was a good approach that we've done to improve the engine and obviously improve the experience for developers who are targeting mobile. Along the way, we also had to update GPU drivers. That's kind of hard because that's also tied into OTA updates. But with Unity, it was slightly easier, and obviously, since lots of developers use the engine, we get lots of feedback as well. So developers can say, hey, this is slow, hey, this is crap. We know, and we get this feedback, and obviously we don't reply to everything at the same time, but we sort of add it to our bucket list and make sure it's fixed. And the main point that's below, we want to guarantee our Galaxy flagship series its support for the Unity engine, which to us is very important as it has a very big market share in the mobile world, and pretty much other platforms too, actually. Okay, also what I'd like to say is lots of Galaxy devices will support Vulkan. This says more, but I'm saying lots, because there's also the S6 as well. That's not added to this slide, can't really fit it. But there's the S7, S8, but this device is a mid-range, sort of similar to the S7, but with a different driver version. That's called the A5, and it launched with Vulkan supports. We've noticed throughout our games, we've actually run Vainglory on the A5, and for a game that shows a 5% gain on the S7, we've noticed a 13% gain with the A5. I don't like giving numbers like that because they can be kind of meaningless, but what we mean is like under stress. And obviously, this has to do with the hardware because the hardware is different compared to an S7. But it's it's an estimate. It's not something that you should take as in every game is going to run 2% faster. But it is still an interesting figure. Okay, so that's pretty much the bulk of the talk. It's very short, but that was essentially what my point was. We are very interested in every developers, indie, anything that's targeting Samsung. And we want you to reach out to us so we can make sure that your game runs properly on our devices, obviously if you are interested in that. And if you are, then please reach out to this email address. My private email is on the second line, and the other one is sort of our email alias that gets sent to us. I don't have visibility to that, so if you want to reach out to me, preferably please send me a private email or just ping me on Twitter.
Over to Alex. Awesome, thank you very much. Okay, so whenever I talk with game developers, people working on virtual reality things, simulation, a common complaint or challenge that comes up is how do we get the player to do what we want them to do or to look where we want them to look? And there's a lot of different ways that we can do this. I mean, I am a composer and I'm a sound designer, and personally I like to encourage people to look more into the audio side of things to help move the player along. So in the speech, I'm going to show you a few cool things that you can try in Unity with regards to enhancing the audio experience. And I'm also going to show you a few of Unity 5's new audio features. If you're an audio person, you probably noticed that they have things like a mixer now, which is insanely fun. And so we're just going to go from there. So once again, I'm Alex, and I know that this is a really boring looking level. I promise we'll get to something sexier soon. But I'm not a level designer, and it's easy to show what we're talking about. So I'm going to play you a piece of music, which you probably heard a little bit before we came in. And yeah, I'm not going to play you any. Okay, there we go. Did you all hear that okay, by the way? Good. Okay, so this is a piece of music that you might get from your composer or your sound designer. And you can throw that into the game file. You can throw it in, you can loop, it'll sound good. But what if we want to let the player know that they're heading in the right direction? I mean, this level is pretty straightforward. You walk forward to the block key. But if there's many different ways you can go, if there's a certain corner of the room that you want them to check out, how can they know? And a really, really simple and fun way to do this is to break up the piece of music into different layers. So what I did with this piece of music is I broke it up. We have like the guitar, the synth, and a little bit of percussion in one, which I'll play right now. Right? So pretty cool, pretty basic. And then I took the other more intense sound designy percussion stuff and I put that in a separate layer. Which, just a quick reminder. Cool. Okay. So that I like that because that's on its own it's like okay, but when you add it to the guitar and the synth and all that cool stuff, it really like drives everything forward. So in this level, very like I said, not overly fascinating level. The characters here. So the main track is I just imported it as an audio source, things that you probably do all the time and you're probably quite familiar with. So I won't go much more into that. The second layer, I imported it as an audio source. And I'm going to draw your attention over to the audio source side. So what I did is I took the maximum distance and I took it way down. And so now whenever you see the blue sphere, when the player gets close to that sphere, that is when the volume will start coming up. And then as you go away from it, it'll go quieter. I played around. I would invite you all to play around with the cutoff range. So what I did with this one, I made it essentially incredibly silent or entirely silent when the player's out of the sphere. But as they get pretty close, pretty much as soon as they enter it, it ramps up to 100, and it's fully mixed in. Cool. So I'm going to show this. I would invite you all to just, as I'm playing, to check out this area as it'll kind of illustrate in a visual manner what I'm getting at. Cool. Okay. Cool. So that's a very common thing. You've undoubtedly heard this before in some kind of game or visual experience that you might have played around with. This was a very simple example. I just broke it up into an easy loop that I broke up into 2 different layers. You can do this to infinite amount. I've worked on projects where they've wanted up to 8 or 10 different audio layers, depending on what the player was doing, fading it all in. It was crazy, but it was also really fun. And it's about subtly letting the person who's experiencing your game or what have you, in a very subtly enhancing the experience and letting them know quietly that, or maybe not so quietly, that they're doing the right thing. People react to that. It's really, really cool. When the drums come in, it really gets pumping. So that's a really, really simple thing, which I hope you all check out. Another thing that I want to try before getting into the more technical Unity stuff is a trigger. I hit it easily. So you've all probably used colliders as triggers to trigger whatever. It's often common used with sound effects, walking into something, an audio event's triggered. But what I would like, or I would invite you all to experiment with, is putting in actual music or percussion or some kind of cool sound into those things. So I have, in addition to the other pieces of music, I have this cool kind of gong, bowed gong sound effect. You've heard this in like every single Pirates of the Caribbean movie. And it's fun. And the cool thing about this is it's very cool. It enhances the experience. It's not necessarily a harmonic or a rhythmic thing, so it can go anywhere in the song. So we're going to play this again, and I'm going to walk through that trigger, and it's going to play. But I can walk in through whatever, but it will sound like it's part of the music. So yeah, let's try this out. No. Shit. Sorry, something happened. Why is it not working? Oh, probably because I didn't assign it. Sorry. Okay, let's try this again. Okay, I apologize. I forgot I had to set up. Okay, sorry. Third time's a charm. Sorry, people. Okay. Right? Okay. All right. Thank you for bearing with me. But it can go through whenever. Now, let's get into the technical side of things. You probably noticed that gong was a little silent. It didn't really fit into the music well. So we're gonna create a mixer, and I would highly encourage, even if you don't consider yourself a sound designer or a composer or whatever, like just mess around with the new mixer stuff that they have in Unity 5. It's really, really awesome, and it's pretty easy to use. So let's call this Final Mix. Cool. So for those of you, and Unity just froze. Fuck. Okay, doesn't matter. We're going to open it to another thing anyways. So I apologize. I'm so sorry. When I rehearsed this, it worked out fine. Oops. Actually, okay. One more time. Okay, well, we'll use the one that I already had set up anyways. Okay, so we have everything all set up. So this is the master track. This is where everything goes through. So if you don't know, if you're kind of new to this, I would just suggest going under groups, creating 2 groups, one for music, and another one for sound effects. So just in case people who don't know like how this works, basically music will go through the master, sound effects will go through the master, but music and sound effects, they are separate, so we can control them on their own plane. So I'm going to go to the main track, do this nice and quick. Hopefully everything will work. Music. Song trigger. Make sure that the gong actually loads up properly. Cool, and I'll make this go. All right, so hopefully this will all work out fine and dandy. Okay. Okay. So I'm going to come around here. A big mistake that people make when they first kind of start messing with music and mixing is that they try to make everything louder. Go the opposite. The music's too loud. Make it quieter. So I'm going to go, and this is a lot of messing around. A lot of what I do is kind of moving knobs up and down and then seeing if it works. Little quieter. Okay. So I think that's a lot better. And obviously you can mess with this ad nauseum. We're going to look at a new project in a second, which has a little more sound effects going on. So I'm going to open this up. It's going to take a little while. This is actually a prettier looking level. So the last thing I want to talk about is something called ducking, which is, I don't know if it was in other versions of Unity, but they made it a lot more accessible in Unity 5. And basically what it is, if you're an audio person, it's basically sidechain compression, which in total nerd speak is you have a piece of audio and you attach a compressor to it, which is responsible for making the louder parts of the audio quieter. And then that's triggered by a separate audio track. Now that's kind of a lot of jargon. Basically, you can set priority to a certain audio track and have another audio track come down. So we're going to look at this game. Whoops. Which is a game I'm working on at the moment. Just music and sound effects. Don't worry about ambience. I have this set up. It takes a little while to load up. But what we're going to notice is I set the sound effects. So I set a ducking on the music, and I set the sound effects as the input. So when the sound effect audio gets above this threshold, the music's actually going to go a little bit quieter naturally. And you can I'm not going to go over everything over here, but for the purposes of this talk, let's just look at threshold. Don't worry about ratio. Attack time when the compression actually kicks in. So I put that quite low. Release time when it stops. Don't worry about the rest of this. So it'll get moving quite soon. This is a game I'm currently working on. It's a 2D platformer. Okay, good. So this, I'm going to go extreme just to kind of prove my point, then I'll bring it back. So you can hear that the music's coming way down to make room for the sound effect. Now again, that's a little much. You probably don't want that much. I'll play a little bit so you can hear something else. So you see, and so I encourage you to check that out, maybe play around with it. I mean, don't go overboard, obviously. It's meant to be like a final thing to help really help everything sit in the mix. But yeah, thank you. That's my presentation. I know that was a lot, and it's the fourth speech, but thank you very much.